Alright, with the through bolts here out, my little GE motor is ready to take apart. Let me just open her up for you. All I have to do now is pull it apart. You have to use the screwdriver here. It doesn't really want to separate, but they put these slots on the side of the motor that allow you to pry it open. There it goes. And the back. There it goes. Okay. Alright, this right here, this is called the squirrel cage. Now, most motors, these split phase motors or capacitor motors, this is what would normally be spinning around. See, as you can see, this is the center part of the motor where the tag is. There is no windings. There is no windings in the end cap. This is the front of the motor. There is no windings in the back of the motor. This hole's where the brush goes, the brushes. The brushes are, where are they? Right here. They're mounted to this Bakelite cap that just screws onto the back motor housing. I'm just leaving it there. Here's the rotor that spins around. This is the windings right here. This is all the windings in my motor. Now these windings, there's two sets of windings here. They're hard to distinguish what set's which, but there is two sets. I believe the outer set is the starter windings because they're smaller, and the inner windings are the heavier duty running windings. Now, a motor like this cannot get itself started. If the starter windings ever burn out, well, it's pretty hard for this motor to do anything. It just sit there and buzz. It doesn't have enough strength to get itself moving. So right here, you can see this Bakelite weight. Now what happens is, the starter winding is engaged right now because it's not moving. If I were to apply power, it starts spinning, if it was inside the shell here. And what would happen is, once it gets up to speed, this weight flies out like this. There's only one weight in this motor. And once it gets up to speed, it flies up like this and disconnects the switch right here. You can see the contacts moving. And what that does is it shuts off the starter windings right there. And that stops your starter windings from burning up because you don't need the starter windings running once the motor gets up to speed. When the motor stops, the switch comes back down like that and resets itself and you're ready to go again. Now this is the simplest motor I have to show you how that works. Right here is the commutator plates. This is where the brushes run. There's one brush that runs on the inside and one brush that runs on the outside, bringing continuous power to the windings. I hope this helps. If not, I have a Montgomery Ward's capacitor start motor I can take apart and show you, and I have a GE split phase bench grinder motor out in my garage I could take apart. I've taken them all apart before. It's no big deal. And if you want, I will take them apart to show you different starter windings and how different starters are set up. And while I have it apart, maybe you can see the inside of my bearing here. You can see a small groove cut in there for the oil channel. This motor is in like new condition mechanically. There is no wear on this thing mechanically. No play in the bearings, nothing. This motor is pretty nice. And I'm going to put it back together again and mount it back on my base so I don't lose anything, because I like this motor a lot. Until next time.